At the distance where Sagittarius A star is located, only 1 in 10 billion photons of light can reach it because most of the photon particles that are sent its way are absorbed by other space elements before arriving at their destination. So scientists opted to measure the radio emissions from the gas around the black hole because radio waves are much more visible than light when passing through gas. The orange colors in the image of Sagittarius A star are actually representations of the radio waves. After half a decade of probing the skies with multiple telescopes from different locations, a coalition of astrophysicists have discovered the heart and soul of our universe, the Sagittarius A star. Located about 27,000 light-years into deep space, this supermassive monster is a scary phenomenon made even more mysterious by its similarities with the Messier 87 black hole, also known as M87. The M87 can be found about 50 million light-years away from our Earth in the Virgo cluster of galaxies, meaning it is farther into deep space than Sagittarius A star. A pictorial comparison of these two black holes clearly shows that there are a number of similarities between them. That's because black holes only respect one law of nature, which is the law of gravity. And gravity, as you know, is constant regardless of scale. But make no mistake to assume that they are the same, because they share quite a few differences as well. The M87 is about 2,000 times larger than Sagittarius A star, but interestingly, the latter is 2,000 times closer to our Earth. Both are believed to have been formed during the Big Bang, about the same time that our universe was formed as well. Sagittarius A star is 30 times wider than our Sun, with a diameter that measures 14.6 million miles. Sounds really big, right? Well, not in the cosmic world. Close analysis shows that the size of this enormous black hole in the Milky Way galaxy is equivalent to spotting a piece of donut on the moon. Since then, the Milky Way galaxy has continued to grow by eating up smaller galaxies around it in a process known as cosmic cannibalism. And that's how it became the big galaxy it is today, measuring about 100,000 light-years in diameter. The cosmic cannibalism phenomenon continues even to this day, and you can expect that the Milky Way will become even broader in the coming decades. For now, though, it features 4 major spiral arms and a number of fragmented arms. The Sagittarius A star acts as a fulcrum around which the spiral arms of the Milky Way galaxy orbit. In other words, everything within our galaxy, including our solar system, rotates around Sagittarius A star. This area is dominated by a huge cloud of gas and dust, making it difficult for scientists to properly examine the elements around it, hence the setback in discovering Sagittarius A star. And even when it was discovered, the existence of this bizarre black hole was barely proven. In fact, it was nothing more than a mythical assertion backed by mathematical models, theoretical calculations, and computer simulations. However, a coalition of about 300 space scholars from 80 scientific institutions across the world set out to change that in 2017. To accommodate the complexities involved in the process, these scientists deployed 8 individual telescopes from 6 different locations to create a giant observatory called the Event Horizon Telescope. 1 new spyglass was later added, expanding the network to 9 observatories from 7 geographical locations. Together, these telescopes were used to capture a high-resolution image of Sagittarius A star using observations of light, a daunting task that seemed impossible at the beginning. I think it's really cool and unique that we can even see a black hole. It's extremely far away and it's dark, and you're not meant to see a black hole. It traps light, and here we are capturing something that's meant to be invisible. Ziriansi, one of the astrophysicists who worked tirelessly on this groundbreaking project, said. And he was absolutely right. One of the biggest mysteries about black holes is that they are not meant to be seen, not even by the sophisticated eyes of expensive space telescopes. That explains why the team of scientists required 9 different telescopes to get 1 image of Sagittarius A star. But the discovery was only the advent of more scientific research work to come. They wouldn't be surprised, though. Prior to the discovery, the team had gathered all the required data in 2017, about the same time they obtained the data for the M87 black hole. However, more work was needed over the next 5 years before they could eventually capture and release the image of Sagittarius A star. During this time, scientists worked overtime developing intricate computer algorithms and programs to support their mission. They collected as much data about Sagittarius A star as they could and refined it using a supercomputer. This supercomputer produced and compiled millions of different images to produce the final image, requiring a processing time that is equivalent to running 2,000 laptops at full speed for a year. The outcome of this diligent work is the extraordinary image you have on your screen. But don't be fooled by the stunning looks. Scientists say that this supermassive black hole is mostly dormant as it only absorbs gas or dust periodically. Its mass is about 4.3 million times that of our Sun. Despite this huge mass, Sagittarius A star is known to swallow matter very slowly. For perspective, if this black hole was human, it would need 1 million years to swallow a single grain of rice. Although we only got this image of Sagittarius A star in May 2022, the very first sighting of this mystery hole was made by Reinhard Genzel and Andrea Ghez in 2008. However, scientific theories around this central black hole have existed since the 1930s, when American physicist Carl Jansky discovered a radio signal transmitted from the Sagittarius constellation to the center of the Milky Way galaxy. Then Bruce Ballack and Robert Brown found that the galactic compact radio source of Sagittarius A star many years later in 1974. But it wasn't until 1980 that scientists got hints that the central compact object was indeed a black hole. Fast forward to 1994, Reinhard Genzel and a team of scientists from UC Berkeley performed an experiment to create a theoretical compact object that weighed 3 million times that of the Sun using infrared and submillimeter spectroscopy. Over the next few years, scientists continued to explore and investigate different celestial objects in search of Sagittarius A star. Little did they know they'd have to wait until 2018 before conclusive evidence arrived. Emissions triggered by fast-moving magnetic interactions from hot gas clumps around Sagittarius A star were monitored by cosmic scientists using the European Southern Observatory telescope. The results obtained matched the hypothesis presented in the past about hotspots rotating close to a black hole with a mass of 4 million solar masses. Nonetheless, astronomers still found it hard to understand the concept. Black holes in general are difficult to spot or study, more so because they do not emit light, and they also swallow everything that comes their way, including photons. So back then, scientists were limited in their observation of Sagittarius A star, but things have since improved thanks to the advancement of technology and several new innovations that are being introduced from time to time. The widely accepted technique to capture an image of a black hole is by observing the cloud of gas and dust around it. But for supermassive black holes like Sagittarius A star, the process is complicated. First, they are usually far away from us, and like other black holes, they are encircled by gas and dust that cluster around the center of galaxies. And even though they sound enormous on paper, they're incredibly small when referenced on a cosmic scale. At the distance where Sagittarius A star is located, only 1 in 10 billion photons of light can reach it because most of the photon particles that are sent its way are absorbed by other space elements before arriving at their destination. So scientists opted to measure the radio emissions from the gas around the black hole because radio waves are much more visible than light when passing through gas. The orange colors in the image of Sagittarius A star are actually representations of the radio waves. Discovering Sagittarius A star is seen as a huge achievement for cosmic scientists. It has triggered quite a lot of buzz and interesting conversations among scholars and space enthusiasts. However, there's plenty of work still to be done. So far, the discovery of this black hole has inspired the creation of 10 scientific papers, and you can be sure that many more will be released in the years ahead as astronomers continue to seek more knowledge about the heart and soul of our galaxy. Be sure to check out this next video over here.